Hello, and today we are doing a esterification with isopentyl alcohol and acetic acid, or a Fischer esterification. So first thing you will want to do, grab your 100 ml round bottom flask out and set up your reflux apparatus, and then you're going to add all of our reactants, 16 mils of the tert amyl alcohol, also isopentyl alcohol, and then we have 22 mils of glacial acetic acid, and finally we have 1 mil of concentrated sulfuric acid. This just acts as a catalyst to get the reaction going, so that is why we have such a small amount. And then set up round bottom flask, set it in there, and there we go. And turn on your heat to about 40, and now we are going to let it boil for 1 hour, and then we will see what happens. Okay, so it's been an hour. We will shut our reflux off and remove it from the heat, and then let it cool down so it's not burning hot. And once it cools off, we'll go to the next step. So now that it's cooled off, we will add it to our separatory funnel, and then we will also add 50 mils of cold distilled water. So once we have everything added, we're just gonna shake it like we normally do. You should have 2 layers. Remember, the bottom layer is your aqueous layer, which is water, acetic acid, sulfuric acid, and then the top is your organic layer. Right. So now we have our bottom layer drained, our aqueous layer, and we're going to add 25 mils of 0.5 molar sodium bicarb. You're going to use your glass rod to kind of stir it up at first because it's going to make a lot of CO2, and then once you have it stirred, it's not making as much gas, then put your stopcock on, or your stopper, and then invert it, degas it, just like we have done. So as you can see, that is a very vigorous amount of gas being produced. So we'll just stir it and do this for a minute or two until it kind of calms down, and then we can put our cap on. Okay, so there's more gas being produced. So this part so you're going to need 3 beakers because you're going to want to keep all of your aqueous layers separate. Reason being is we want to wash it with 0.5 molar sodium bicarb until this red litmus paper, when we put it in, turns blue, because that means that the solution is now neutralized. So that's our second wash here. You can see this is a clean beaker because we are keeping them all separate, keeping them in order. So we'll drain this out, and then once this is done, then we will put a red litmus paper in it and see if it turns blue. Okay, so drained our 3rd layer. See if I can get the camera to focus on this. So this here was our first wash. You can see the witness paper is still red. This is our second wash, it is blue, and that's our third wash, it is blue. So could have stopped at the second one and that would have been plenty good. This is more so to show you once it's done it turns blue. So it might take 3 washes, not going to be the same for everybody, so just pay attention to your litmus paper. But as you can see, there's a very clear difference between the red one on the left and the blue one on the right. So we can drain this into our little Erlenmeyer flask, and then you can use some calcium chloride as a drying agent, and then leave it to dry for about 10 minutes. And in the meantime, you can set up your distillation apparatus. So our final step, we decant from our little Erlenmeyer flask into our 50 ml round bottom flask and set up our distillation apparatus. And you have your 25 ml down at the bottom here, and you set up an ice bath for it and have it nice and level, and then you just wait and let it do its thing. Okay, so once it's done distilling, then you can weigh your ground bottom flask with product in it, make sure it's really dry on the outside, has no water. My temperature got to 136. The literature or the lab manual says between 135 and 145, so that's good. So that would indicate that it was product formed and came off, and that's all there is to it. And good luck.